Hello and welcome everybody. Today we'll introduce you to another type of reactions of haloganoalkanes, which is called elimination. Elimination of hydrogen halide. We have haloganoalkane. We're going to remove the HCl or HBr or the HI that present in. As we use to make reactions, we have conditions for these reactions. And the condition for this reaction is having sodium hydroxide dissolved in ethanol and presence of heat. And sometimes they can describe this sodium hydroxide in ethanol as ethanolic sodium hydroxide. Yeah, it's like this, ethanolic sodium hydroxide. So don't panic if you see this. On the other hand, since we're using sodium hydroxide, which is the role of sodium hydroxide, it works as a base. Okay, so the general equation for the elimination of hydrogen halide from haloganoalkane as the following. So this equation represents you have haloganoalkane that reacts with sodium hydroxide, and then what will happen? You'll have NaX, in which you have NaCl or NaBr or NaI, depends on the halogen that present in your haloganoalkane, in addition to water, okay, and then this beautiful guy, which is alkene. Put in your mind are considered to be inorganic products, whereas alkene is an organic product. So how can I describe this reaction? As we can see in this beautiful haloganoalkane, we can notice that we have Cl and hydrogen. The process in general is removing H and X. So how can I do this process? Put in your mind, we're going to remove the hydrogen and the X from the two adjacent carbons. In other words, this X is bonded to carbon, and this carbon here, which is the adjacent one, is bonded to hydrogen. So we're going to remove HXs on the two adjacent carbons. So this is the story at that point. So how can I do this process, and how does the OH do this process alone? Let's go and see. So first of all, we have to draw the OH guy in here. It has a negative charge and lone pair. As we can see, we have carbon here and carbon, okay? These are adjacent because we have halogen, all right? That's good. So the first step here is attacking the hydrogen, okay? And just take this hydrogen. As a result of this bond will be broken, just like make a double bond in here. And since this carbon makes 4 bonds, it cannot make 5 bonds, and that's why you will have heterolytic fission in order to break this bond, and this is actually what will happen here. You'll have a double bond, and this is the story. You have hydrogen in here. So this is the process of removing or eliminating the hydrogen halide from haloganoalkane. You will have a double bond, which is alkene. And since the water, the OH, attack this hydrogen, it produce water like H2O. And the rest for the Cl, that is bonded to Na positive, like they attract each other and giving you NaCl. So let's take another example. What will be the product of this compound if we remove the hydrogen halide, like if we add NaOH and ethanol, and here, what will be the process? So if you like to use, let's say, the display formula for this compound, we can do it easily, and then just analyze the question in order to, in a way better. So first of all, I can change it like 1. We have 5 carbons, 1, 2, 3, 4, 5. The chlorine is in the second carbon, and here we have hydrogen. So the process is removing the HCl from this compound. But we can see something. I can remove the hydrogen and Cl from here, or I can remove the Cl from here. In other words, we could have a double bond between the first and the second carbon, and we could have another double bond between the second and the third carbon. Does it mean like you'll have 2 compounds? Yes, you will have 2 compounds. So at that point, you will have an alkene with a double bond on the first carbon, like this. You have double bond, 1, 2, 3, 4, 5. We can put them here. And since we're dealing in the test, it's better to draw them in structural or scalar formula. 1, 2, 3, 4, 5, and the double bond is in the first carbon. And this is compound 1, and the second compound, you'll have a double bond between the second and the third carbon, so it becomes like this. If I ask you to call this compound or to name this compound, we can see that it's composed of 5 carbons. Double bond is in the first carbon, and that's why it's pent 1N. But if I ask you to name this compound, you can notice that it contains a geometrical isomer, whereas this guy here does not contain geometrical isomer. So the geometrical isomer could give you cis or trans. So how can I draw this in terms of cis and trans? So as we can see, we have 5 carbons. So we can draw that in terms like this. Okay, and since you have 2 hydrogens that are diagonal to each other in terms of trans, so I can call it a trans pent. The double bond is between the second and the third carbon, so we can say it's 2N. This is the cis. All right, so we can say this is 1, 2, 3, 4, 5, and it's called cis pent 2N. So this compound contains geometrical, they're cis and trans to each other. Okay, so let's take another example. And the question is, how can I do this process in terms of elimination? What will be the products? As we can see, the products like the inorganic ones, it gives you NaBr plus H2O, which is like usual. And now let's go to the organic compound. By the way, the inorganic compounds that are produced in here are NaCl and water. First of all, you have to look at the Br, and we have carbon in here, and what are the adjacent carbons. So suppose that I cannot deal with such skeletal formula. It's a bit hard for me. I cannot deal with it. You can translate this drawing into something like a bit easier. So we can say 1, 2, and you have carbon here. You have 1, 2, 3, 4 carbons. Okay, and you have a branch of methyl on the second carbon. It contains 3 hydrogens, and we have Br. And don't forget the hydrogens around there. So the first step here is determining the carbon that contains Br and the adjacent ones. This is adjacent, this is adjacent, and this is adjacent. And by the way, those 2 guys are identical, so I'm going to use one of them. Okay. So the target is removing HBr, okay, from the 2 adjacent carbons. We can remove hydrogen bromide from here, or hydrogen bromide from here. In other words, we could have a double bond in this area or in this area. So what will be the drawing after doing that? So the first one, you will have a carbon double bond, and you have C, another C, another C. I can draw it in terms of a skeletal. Since you have 4 carbons, you have 1, 2, 3, 4. The double bond is in between the first. This is the first compound. The second compound when it's in here. So we can draw 1, 2, 3, 4. The double bond is in here, and we have a C like this. All right, yes, here we go. I just want to put you up here. So I can translate this compound in terms of a skeleton. I have 4 carbons, the double bond is in the middle, and you have alkene. So this is compound 1 and this is compound 2. If I want to name these compounds, we can find the longest chain, 1, 2, 3, 4, then it's bute, and the double bond is in the first carbon, bute 1En, and we have methyl on the second carbon, then it becomes 2 methyl bute 1En. And if you want to name this compound, you can notice that 1, 2, 3, 4. So it's bute The double bond is in the second carbon, and then that's why it's en. Methyl group is in the second carbon. We can say 2-methyl butene. And if I ask you, does it contain geometrical isomer? The answer for sure is no, because the carbon in here has 2 identical groups, and the carbon here has 2 identical groups which are hydrogens, and that's why no geometrical isomers are in here. One more thing to describe, which is ionic equation. So how can I deal with it? Just want to give you, let's say, CH3, CH2, Cl. If we add NaOH, okay, what will be the products? For sure, as we said, it becomes NaCl plus water plus C2H4, which is the alkene. If I need to write the ionic equation for this repeat this in terms of CH3, CH2Cl, I cannot split it since it's a covalent compound. OH negative plus Na positive, it gives you Na positive plus Cl negative plus H2O plus C2H4, and we can cancel out the Na positive in both sides. So if you want to write the net ionic equation, it becomes CH3 CH2Cl plus OH negative gives Cl negative plus H2O plus C2H4. You have to put this in your mind.